2, 3.
What's up, team? Today we're going to talk about rectangles and how to show that some quadrilateral is definitely a rectangle. This is similar to the parallelogram lesson we did previously. Today I have 4 potential conditions. If you can discover one of them out in the wild, then you definitely have a rectangle. Let's talk through all 4. First of them, if you can find or show that some quadrilateral has exactly 4 right angles, then you definitely have a rectangle. So what that might look like up here, if this quadrilateral has 4 right angles, then it's definitely a rectangle. That makes sense because that's kind of the definition of what a rectangle is. So no surprises there. Number 2, some parallelogram with exactly 1 right angle is all we need. So that means we know it's a parallelogram, meaning the 2 opposite sides are parallel to one another, and it has exactly 1 right angle. So if this is all the information you have, you can definitely say it's a rectangle because, well, if these sides are parallel, that means these 2 lines are acting as transversals. So we have same side interior angles going on right here. So they must be supplementary, add up to 180 degrees. 90 plus 90 is 180. Similarly, these 2 same side interior as are these. Well, now we're back where we started. We have 4 right angles in our quadrilateral, definitely a rectangle, no surprises. Number 3, if you can find some quadrilateral with 4 congruent angles. So that means we have them all being the same. They're not necessarily right angles. You're not given that information, but you know that they're all the same. That's enough to say that it's definitely a rectangle because if they're all the same, and we know that the interior angles of any quadrilateral ever must add up to 360, well, you have 360 divided by 4. That's 90 degrees. That means all 4 of these angles are exactly 90 degrees. They must be right angles. Therefore, it's a rectangle. Cool. The 4th and final condition that you can use to prove that some quadrilateral is definitely a rectangle is if you have a parallelogram with congruent diagonals. This one's a little bit more abstract, I suppose. So we have diagonals here, and they're congruent to one another, meaning all the way across. So if we have A, B, C, D, we know that AC is congruent to BD. That would be given information. Additionally, in this case, we must have a parallelogram, not just any quadrilateral, but a parallelogram. So one of the definitions of parallelogram is that opposite sides are parallel to one another like this. Okay. One of the definitions of parallelogram is that diagonals bisect one another. We've discussed that previously. So if the diagonals bisect one another, these 2 chunks, those 2 segments must be congruent to one another. We'll call this intersection point here E. And if these 2 are the same, these 2 are also the same. Notice I used a single tick mark on all of them because if BD is being chopped in half and AC is being chopped in half, well, the halves are going to be the same length because the entirety of the lines are the same. So now we're in this situation where we have, it doesn't look like we necessarily have a rectangle, so we don't know anything about the angle measures. But what we do know is that the top and the bottom triangles must be congruent by side, angle, side. There's the vertical angles going on here. So if that's the case, we have 2 congruent triangles. Not only do we have 2 congruent triangles, but they're 2 congruent isosceles triangles because the 2 legs have the same length, meaning base angles must be congruent on both of them. Okay, nice. How does that show rectangleness? That's fair. Let's look at the left and the right triangles now. Triangle AED and triangle BEC. Very similarly, we have vertical angles here. So we have side, angle, side, side, angle, side. 2 congruent triangles. Cool. And they're also going to be isosceles. Boom, 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 boom. So we have these base angles going on here. Now, what we have is each corner, the entirety of angle A, the entirety of B, the entirety of C and D, they're composed. We don't know the actual angle measures. I want to be very clear about that. We don't know what they are, but what we do know is that they are composed of the sum of, well, the one that we marked with a single little line here and the one that we marked with a double angle indicator here, and they're all exactly the same. So we don't know what they are, but we know that they're the same. That harkens back to what we just did a moment ago. If we don't know what the angle measures are, but we know that they're the same, they must end up being 360 divided by 4. Therefore, they're all right angles. Therefore, if these conditions are met, where you only know that you have a parallelogram with congruent diagonals, that's enough to say that you definitely have a rectangle. Okay, let's walk through a proof in a moment. Okay, let's talk about this proof. Just like last time, I'm not interested in the two-column proof. I just want to talk through it. I want to become convinced that this stuff is true by looking at pictures and maybe talking about it a little bit. So we have this figure here. It's named Gram, G-R-A-M. It appears to be a rectangle. Our task is to show that it's a rectangle, but we don't actually know that it is yet. We have some given information. Our job here is to connect the dots and convince ourselves it's a parallelogram. So, to convince ourselves it's a rectangle. What's given to us is that it is a parallelogram. That's given information. So we'll just kind of keep that in our back pocket for a quick second. There's a lot that we can do with that information, and let's just kind of see where this goes based on our other information. What's also given is that triangle GRM is congruent to triangle RGA. So let's note that. Let's go find those pieces. I'm using green for GRM, so that goes from G to R to M. We have that green triangle there. And then RGA, I'm going to use my red pen. Hopefully it's distinguishable in the video. RGA goes from R to G to A down here. So they're kind of overlapping. The green one is kind of the top portion on the left, whereas the red one is kind of the top portion on the right. They overlap kind of awkwardly here, then they have their own little space. We're not even using the bottom portion of this potential rectangle, I suppose. So let's figure out what the consequences are of this particular fact. I'm noticing that both of these triangles occupy one of the diagonals. The green one occupies diagonal RM, whereas the red one occupies angle diagonal GA. So if we look at our statements up here, I'm noticing that RN is the second and third letter in the statement, whereas GA is the second and third letter of the statement. We know, based on triangle congruency we've studied previously, if that's the case, then RM must be congruent to GA, because they are the second and third letter in this statement. Well, RM is the diagonal, GA is the diagonal, so now all of a sudden we definitely know that our diagonals are congruent to one another. Seems like maybe that's not a big deal, but it is a big deal, because this statement here, number 4, it says if we can show that we have a parallelogram with congruent diagonals, then we definitely have a rectangle. We're almost there. We've showed that this figure, this quadrilateral, has congruent diagonals. Now we just need to show that it's definitely a parallelogram, so that both conditions are met. But wait, look, the given information, GRAM is a parallelogram, so we didn't even have to show it. It was given to us. So we've satisfied this condition. It's definitely a parallelogram because it's given. We didn't have to work for it. We just had to look. And then we use this information about the triangles being congruent to show that the diagonals are congruent to one another as well. We only had to satisfy one of our 4 conditions. The 4th condition is here. We satisfied that. Therefore, GRAM is definitely a rectangle. All right, let's dive into some practice problems. Let me know if you have questions. You got this.